We're ready to begin chapter 4, which is all about exponents and irrational numbers. So we're starting today in section 4.1, integer powers of 10. I have talked a bit about powers of 10 already. I remember talking about it just last week with you all. Make sure that you label your sections in your math concept book nicely as you see this here. 4.1 and underline this little title, integer powers of 10. Okay, so let's see, powers of 10, powers of 10. Powers of 10 may be written in standard form or in exponential form. So here we see a power of 10, 10 to the 5th, written in exponential form. So that exponent tells us what? Gabe, what does the exponent tell us?
It's to the power of 5.
So it tells us that 10 is being what? Multiplied 5 times, right? So it's 10 times 10 times 10 times 10 times 10. So 10 is a factor 5 times is what it says. And we know that when we multiply by 10, we're simply having a number grow by one whole place value, right? So 10 to the 5th is what number? 50? Good, so we have a 10 being multiplied 5 times, giving us a number that has 5 zeros. So when you have a power of 10, you can literally look at the exponent and see how many zeros would be found in the standard number. 100,000, that's nice, okay? So what happens if we have a negative exponent? What do you think? Aiden? Good. Instead of moving the decimal to the right and getting a bigger number like we did here, we really are moving the decimal to the left and getting a number that is really small. Okay? And so the other thing it does, if we want to look at this in fraction form, is that negative says that we are going to move this entire power of 10 to the inverse location, which is in the denominator. Okay? So it would be 1 over 10 to the 3rd, which is 1,000. 1/1,000, of course, can be written as a decimal, right? So there it is. As he said, we're going to get a smaller number. So if we include the 0, this is really important. If we include the 0 in the ones place right here, how many zeros are visible in this standard form number? Spencer? 3. And so here's the exponent of 3. See that? And we have 3 zeros in this standard form number if we include that 0 in the ones place. Okay? So we still see 3 zeros, but now we have a 1 way to the right of the decimal. It's 1/1,000. Okay? Jake? Somebody's missing something. Okay, if I have 10 to the 1st, 10 is a factor how many times? 1 time. So what is 10 to the 1st? 10. So if I have 10 to the negative 1st, that negative, again, is just saying move that entire power of 10 to the inverse location, which means down to the denominator. So it's 1 over 10 to the 1st, which is just 1 over what? 10 to the 1st is? 10, you already said that. Okay? 1 over 10. So when you have a negative exponent, that negative is telling you move the entire term to the inverse location. So let me try this. What if I have this? 1 over, let me start with this, 10 to the 1st. 1 over 10 to the 1st is just really 1/10 again, right? We didn't move anything, did we? Because there was no negative exponent. But if I have 1 over 10 to the negative 1st, now that negative says move this whole power to the inverse location. And where is the inverse location? If you are starting in the denominator, it will be the numerator. So we bring it up here. And this is 10 to the 1st now. And again, 10 to the 1st is 10. Okay, so we're learning that a negative exponent is saying move this term to the inverse location. If it's in the top, move it to the bottom. If it's in the bottom, move it to the top. Let's try a few. And pause and come back when you have answers to this. Okay, so here are your answers. Notice 10 to the 6 has 6 zeros, so it's 1 million. 10 to the negative second has, it's 100th, isn't it? So 2 zeros, as long as we show a 0 in the ones place. 10 to the negative 7, we said is 1 10 million. 10 to the negative 1 is 1 over 10, or 1/10. 10 to the first is 10, and 10 to the 0 we just learned is 1. And the number one error here, the number one error is that people will say 10 to the 0 equals 0, and it doesn't equal 0. That's a very sad face. It does not equal 0. And if this class can get through the quiz and the test without stating this, that 10 to the 0 equals 0, if every single person, and make sure that you always state this, that any number to the 0 equals 1. Aiden just asked, does this work for any number? And it does. If I have 2 to the 0, what does that equal? 1. It works for any number, and I'll tell you how later.
If it was 20, it would be 1.
As we go into properties of exponents, I'm going to show you more examples why this is true. Okay? Here's one example as to why it's true. 10 to the first. 10 to the first is simply 10. You know that. 10 to the negative first, we just said, is 1/10. And if you multiply those together, what do you get? 10 over 1 times 1 over 10, you get 1. And you're going to learn a property of exponents that says you simply, when you multiply two powers like this, you simply add these two. And 1 plus negative 1 is 0. The whole thing equals 1. Okay? Everyone should be sitting up straight. Using a negative exponent. Very tricky. It's all about location, isn't it? As we've said. So let's use one in this example here. You need to take down this example. A millisecond, milli is a prefix meaning thousand. So a millisecond is 1,000th of a second. Use a power of 10 to write this time in seconds. So write that sentence down, those two, and then answer it. Okay, so what do you think the answer is, Lauren?
10 to the negative 4.
She's thinking 10. She says 10 to the negative 4, which would look like this. Is that 1,000? Is that 1,000? Or is that a little too much? It's actually 10,000. Okay? So we have tenths, hundreds, thousands, 10,000. So what would it be instead?
To the third.
Good, negative third, which would be there. 1,000th of a second. This is how you would write it, as in exponential form or in standard form. Write this number as a power of 10 in exponential form. It's written in standard, so let's write it now in exponential form. The answer is 10 to the, good job, negative 4. So again, we can write numbers both in standard and in exponential form. So let's take down a rule box for this. Integer powers of 10. In other words, when we take and put an integer as an exponent using the base number 10, what are the possibilities? We can have an exponent that is a positive number. So these would be our whole numbers. That could be written as a rule this way, 10 to the nth, some number that is a positive number. And when we do, as you've seen, we repeat the base 10 n number of times. So if I have 10 to the second, that equals 10 times 10. If I have 10 to the third, that equals 10 times 10 times 10. Just repeats the multiplication that many times. The next possibility was having a negative integer, though. And in this rule box, we want to be very clear what the negative does to the expression. And so what does the negative do? I've already said this a number of times. What does it do? Stuart. Good. Okay, so it multiplies the inverse that many times. So if I have 10 to the negative 3, it really is as though I'm multiplying 1/10 times 1/10 times 1/10. And it moves the decimal to the left rather than to the right. And finally, we have that really interesting special case, whoops, where 10 could be raised, a number could have a 0 exponent. Any base to the 0 equals 1, right, equals 1, no matter what the base is, okay? So make sure this is in a nice box. You've boxed it up. You could even highlight it. This is an important rule box that you will use today and this chapter. We have about 15 minutes today before lunch, and then you have another 20 minutes after lunch, so there should be no problem finishing this assignment in class.